All right, welcome to the end of 3.1. Just have a little example problem. Nothing new in this example. You can skip this video if you'd like. All right. This is just combining stuff from last chapter with the product and quotient rule. All right, so we have a box. Anytime you're looking at a problem like this, and you say you have a box, draw yourself a box. All right. And it specifies that this box has one side that's only 1 meter long. The other sides, who knows? But for whatever reason, one side of this box is only 1 meter. The other side of the base and the height, who knows? Give those whatever variables you'd like. X and Z are also good choices. And that's what we have here. So we have some costs. The materials for the sides are going to cost something. The material for the bottom and the top are going to cost something. And we want to maximize the volume. Right? So that's going to be our objective function. We're maximizing the volume. What is our constraint? Is that we only have $240. The cost equals 240. We have our objective function and our constraint. We just have to, get some variables in there. So what are we maximizing? We're maximizing the volume. The volume of a cube, this isn't a cube. The volume of a box is the base times the height. And the base is 1 times x times the height. This is our volume of a box with one side that's only 1 meter long. And then the cost has to be $240. The cost is the tricky part here, right? The cost of the bottom plus, now 2 of these sides are going to be the same. And 2 of the sides are going to be different, right? Maybe it would have been better if I stretched this box out. So 2 sides plus another 2 sides plus the top. And all of these have different costs. Oh my word. We just have to find the cost of all these things and just add them up together. All right, and that's going to be our constraint. So the top is $20 per square meter. And the sides and the bottom, and I think I can do this because I think this is the mark of where the notes are going to end. All right. Oh, I can't read the problem. All right. Top is $20 per square meter. The bottom is $10. So the bottom is going to be $10 per square meter. What's the area of the bottom? Length times width. Area of the bottom is just x. So the cost of the bottom is going to be 10x. Plus 2 times the cost of this side, this front and back side. Again, the base is 1 meter, the height is y. Plus 2 times the cost of this side. This side costs $10 per square meter, and there are xy square meters. It's going to be 10xy. I'm definitely missing a cost of 10 a little earlier on. It's going to be 10, right? 10 times 2y, or 2 times 10y actually, if I'm consistent. Goodness. All right, and then plus the cost of the top. And the cost of the top is $20 per square meter. What's the area of the top? Well, it's the same as the area of the bottom, right? Which is just x. So we have our volume. That's our objective function. We can simplify this constraint equation just a little bit. Let's simplify this a little bit, right? This is 240 equals all the x's. 10x plus 20x is 30x. And then 20y, we have that. And then we also have a 20xy. All right. That corresponds to the cost of one side, cost of another side, cost of the top and the bottom together. So let's carry that on over to the next page. We're maximizing the volume, which is x times y here. And our constraint is that we only have $240. So 240 was 30x plus 20y plus 20xy. This is a bonus application problem. It is from the homework and it is kind of long. It's kind of messy. So strap yourselves in. This is going to get just trying to show you some of the messier problems instead of only doing the easy problems on the videos, right? Give you a chance to see what can happen. All right, and I always get a little nervous with these ones, but it's all right. So for these constraint equations, for constrained optimization, like in the previous chapter, we want to solve for one of these variables and plug it in to our objective function to make our objective function only have a single variable. So we have to either solve for x or y. We have this xy term, so it's a little trickier, but it's not too bad. Let's solve for y. All right, it doesn't really matter. So if we solve for y, right, we have to subtract 30x from both sides. What that gives us is 240 minus 30x is equal to 20y plus 20xy. And now we'd like to combine these so we can divide by their coefficient, but it's not easy to combine. Because they're not like terms, right? One of them has an x. So on the right-hand side, what we're going to do instead is we're going to factor out a y. We're left with 20 plus 20x. And now we can divide both sides by the coefficient of y, which is 20 plus 20x. Okay, we'll do that and we'll have finally solved for y. Well, not super exciting. This is only the start. So if we do that, we're going to get y is equal to 240 minus 30x over 20 plus 20x. And remember, you can't cancel here unless you factor first. Everything is divisible by 10, for example. If you wanted to, you could divide everything by 10 and get 24 minus 3x is equal to 2 plus 2x. And then you're not going to be able to cancel anything else other than that. So we take this constraint, we replace this for y. We're going to get the volume is equal to x times that. The volume is equal to x times all of that, which we said was 24 minus 3x, all over 2 plus 2x. And we'll simplify and take the derivative. X we can think of as x divided by 1. Multiply those numerators. We get the volume is equal to 24x minus 3x squared over the denominator, which is just 2 plus 2x. We want to find the maximum of this, so we're going to take the derivative. To take the derivative of this, we're going to need the product rule. Here we go. So low, 2 plus 2x, that's a g, times the derivative of the top, 24 minus 6x, minus the top function, 24x minus 3x squared, times the derivative of the bottom function, which is just 2. Square the bottom, and away we go. We want to know when this is equal to 0. Don't worry, it's not as bad as it looks. We want to know when is this equal to 0. Well, the denominator can never equal 0. We don't want the denominator equal to 0. A fraction is only equal to 0 when the numerator is equal to 0. Another way of thinking about it is we can multiply both sides of this equation by the denominator when we set it equal to 0. All right. So whether we multiply both sides by this denominator and canceling it out, and again, we're setting that left-hand side equal to 0, or whether we use the logic that a fraction is only 0 when its numerator equals 0, Either way, we only have to worry about when the fraction is equal to 0 here, or when the numerator is equal to 0. All right. So let's simplify that numerator a little bit. We get 0 has to equal, well, FOIL out that first pair in the numerator. Going to give us 48 minus 12x plus 24x minus 12x squared. And we'll think about this as a negative 2 right here. We'll distribute that negative 2. Comes minus 48x plus 6x squared. And we'll combine like terms. So let's look at the quadratic part first. Negative 12x squared plus 6x squared. It's going to be a negative 6x squared. Linear terms next. Minus 12x plus 24x is positive 12x. Oh, negative 36x. And finally, there's just a 48. We want to know when this is equal to 0. If we divide everything by negative 6 or factor out a negative 6, it'll be easier. I'm going to divide everything by negative 6. That makes this positive x squared. Divide out by negative 6, positive 6x. Divide by negative 6, minus 8. Ooh, this looks kind of nice. This is a nice little factoring problem. We need two things that multiply to negative 8 that add to 6. We're going to have x plus 8. No, wait, hold on. Wait, is this not good? Am I off by a sign? It'd be 2 and 4 if the signs were different. Oh no, what have I done? Not 2 videos in a row. All right, let's look at this. Because this doesn't factor as it is. It looks like I'm off by a sign somewhere. Or maybe we have to use a quadratic formula, but I think the chances that we have to use a quadratic formula is pretty low. I'm going to pause the video and then I will figure it out and then I will resume it with another video.